In this video, we're going to review some key features of functions. So we're going to take a look at a couple of examples to get us started. For example 1, they've graphed the polynomial for us, but if in an example it's not already graphed, you can type it into Desmos and look at the graph in order to pick everything out. So for number 1, they're asking for the domain. So we want to think of how far does this graph go left and right. And we're thinking about the x values of our graph. So this graph is going left continuously, and it's also going to the right continuously. So we would say that it goes from negative infinity to positive infinity for the domain. The range is the lowest y value to the highest y value. So you think of how low the graph is going, and it is going down on both ends of the graph forever. So that's negative infinity is our lowest point on the graph. And it goes up to where y would equal 0, but it doesn't go past the 0. And then it's equal to 0, so put a bracket with the 0. For our x-intercepts, we have -6 and 2, so let's write those as an ordered pair. -6, 0, and 2, 0. For our y-intercept, it looks like it's located at -5, so again, write that as an ordered pair. And then for our end behavior, you look at the ends of the graph and where are they infinitely going to go. So this looks like it's headed toward the 4th quadrant on the right, where everything would be positive for x and negative for y. And on the left end of our graph, it's in the 3rd quadrant where the x is negative and the y is also negative. So we write out as x approaches negative infinity, y approaches negative infinity. And on the other end of the graph, as x approaches positive infinity, y is approaching negative infinity. Okay, let's scoot over and look at the topics on the right side of the page. So it asks for turning points. So the turning points on our graph are the relative minimum and maximum points. So we have 3 turning points on our graph. One is at -6, 0. One is at -2, -8. And the other one is at 2, 0. So let's write all of those down. Now, intervals of increase and intervals of decrease, we want to focus on the x values at those turning points. So I'm going to erase the point and just put the x value. So this one turns at -6. The relative minimum turns around at -2. And then the relative maximum, that one turns around at +2. And it just might make it easier to look at intervals of increase and decrease. So this graph, let me make that a little smaller. It has an interval of increase from negative infinity up to -6 is an interval of increase. Whoops, let me get my pen. So let's write negative infinity up to x equals -6. But then the graph goes, let's see, the graph goes down between -6 and -2. So it's decreasing between -6 to -2. Then the graph turns around at that turning point and it goes up. It increases from -2 to +2. So write that under intervals of increase. Then it turns around one more time and we have another interval of decrease from x equals 2 to infinity. So there's 2 intervals of increase that I highlighted in green, and there were 2 intervals of decrease that I highlighted in blue. And you always want to pick out the x values that break up your intervals, or they start and stop your interval that's increasing and decreasing. Now, positive and negative intervals, those look at the portions of your graph where y is positive or y is negative. So let me grab yellow. So in other words, y is negative underneath the x-axis. So I'm going to highlight this area of my graph, and that is where this whole function would be considered a negative interval. And so the whole function, like I just said, is in that negative interval. So for all the values of x, they are all in that negative interval. And then no values of this function fell in this positive interval, which is above the x-axis. It's where y is positive is what that's referring to. So let's just put in A for that part. Okay, so that's it for number 1. Let's look at number 2. It says identify the key features of the graph again and asks us for the same things. So let's look at domain to start with. How far does this graph go left and right? Okay, and it's the x values that we're focused on. So left, my farthest left value of x was at -3, and it's equal to -3, so put a bracket. And then I go all the way to the right, all the way to 2, but it's not equal to 2, so I need to put a parentheses with the 2. For the range, I look at the lowest y value to the highest y value. So my lowest y value would be -5, and it is equal to -5 since that was a solid dot right there, so we put a bracket. And then this graph would travel up for the y values up to 4, and it is equal to 4 since that line that crosses through the 4 is solid. So our range goes from -5 up to 4. The x-intercepts would be -2, and then the 2 we would only include if it was positive, but since it's not a positive value, let's just leave that one out. And write only -2 is our x-intercept. Our y-intercept was up at 4, so again, write those as an ordered pair. And then our end behavior is what the ends of our graphs are doing, like where are they approaching. So on the left side of our graph, we have the point -3, -5. So we would say as x approaches -3, y is approaching -5. And on the right side of our graph, that little open circle on the right is located at 2, 0. So we would say as x approaches 2, y approaches 0. That's how that graph is behaving on the ends of our graph. Okay, so let's look on the next side of the page. Turning points of our graph. So we have a turning point at the vertex of this parabola. So it was just located at 0, 4. That's a maximum point, not relative. Intervals of increase and intervals of decrease. So we have an increase in this first interval. Remember, we look at the x values to pick that interval out. So the x value would be -3 up to this x value at the top, which was 0. So from -3 to 0, we had an interval of increase. And then this graph has an interval of decrease. Again, look at your x values to pick out your interval. So it goes from 0 to 2. Now, positive and negative just refers to your y values. So negative y values are down here at the bottom, underneath the x-axis. These are negative. So our negative interval would be this piece of our graph that fell in that negative interval of the graph. It's our negative interval of this function, we should say. So we pick out the x values again. So it goes from -3 up to -2. That was our negative interval of the graph. And our positive interval includes this piece of our function that falls above the x-axis, where y values are all positive. That's what it's referring to. So this was the positive interval, and you pick out which part of your function is in that interval. So it would be from -2 for the x to positive 2. In that part of our function, y was positive. So from negative 2 to positive 2. All right, so we made enough of a mess of number 2. Let's take a look at number 3. So for number 3, we need to type it into Desmos. So let me pull up Desmos, clear out what I have in there, and let's type it in. So we need to type 3x cubed minus 4x. So 3x cubed minus 4x. If you hear a dog snoring in the background, that is courtesy of Scout. So I apologize, but at least he's being somewhat quiet. So we have our domain still goes from left to right. So think of how far this goes left to right. So this graph, by the looks of it, is definitely going left forever, so negative infinity, and right forever, so we put positive infinity. For the range, we look at the lowest y value to the highest y value. And this graph is going down forever, so we put negative infinity. And it's going to go up forever, so we put positive infinity. All right, the x-intercepts, let's pick those out. We've got negative 1 point, let's just round that to negative 1.20, 0, 0, and 1.20. Okay, the y-intercept, so let's take those away, and we just have the one y-intercept at the origin, 0, 0. Our end behavior, so I like to sketch a graph when I can't write on it. So our graph looks like this, and our end behavior is going to be what the ends of our graph are behaving. In other words, like where are they infinitely going? So this first end of my graph is going toward the first quadrant where everything's positive, and the left side of my graph is going toward the third quadrant where x and y are both negative. So we just write that out in Math 3 terms and say as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y also approaches positive infinity. Okay, so I'll just leave my little sketch there, and let's talk about turning points of the graph. So I'm going to actually just sketch my graph right here in the middle so I can continue to draw all over it because that's what helps me out. Okay, so let's write some turning points down. So we have this turning point here and this one down here, a relative maximum at negative 0.7, I'm just going to round it off, and 1.8. And then the relative minimum point was at positive 0.7, negative 1.8. Those were my turning points, so I'm also going to write them over here. Okay, now intervals of increase and decrease, we only need the x value to pick those out, so I'm just going to mark out the y value so we can focus on just that x value. So have an interval of increase there and another one over here. So let's write what those would say. It goes from negative infinity and it increases up to negative 0.7 for my x. So interval of increase is negative infinity to negative 0.7. And then another interval of increase would go from 0.7 up to positive infinity. All right, the interval of decrease is this one in the middle here, and it goes from negative 0.7 to positive 0.7. All right, so let's try, I need to sketch my graph a little bit nicer so that I can pick out the next set of things. Let's see, I think it's about like that on my graph. And I have positive interval and negative interval, so I need these x-intercepts because that's where I need to write my values down. Let's see, negative 1.2, 0, and positive 1.2. And I'm going to try to just clean up a little bit of my drawing so you can see this a little better. So hold on 1 second. Let me get things cleaned up a little bit. Okay, so now we can kind of focus more on positive interval versus negative interval. So for this graph, I have a negative interval below the x-axis. Remember, that's where your function is considered negative because y is negative down below the x-axis. And I would have to say that this interval goes from negative infinity up to that x value right there, negative 1.2. So let's write that down. Negative infinity to negative 1.2. And there's another piece of my graph that's also in this negative interval, and it goes from x equals 0 to x equals 1.2. So let's put 0 to 1.2. For the positive interval, we think of what's above the x-axis, in other words, where y is positive. Which part of our function falls in that interval? And so that would be this little piece right here from negative 1.2 to 0. So let's put negative 1.2 to 0 for x. And also this other little piece over here, which goes from 1.2 to positive infinity. Okay, so that's it for these first few examples.